Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. So we have been doing statistics paper 3 which is of descriptive type, and today we will do econometrics as we have been doing econometrics. So today we will continue and we are moving towards the end of the econometrics, and as we discussed earlier that we have covered almost all of the syllabus of econometrics. Some are left which will be covered in the recent lectures that we'll do in the coming classes. And we till now we have covered simple linear regression model, multiple linear regression model, and some problems related to these models. And in yesterday's lecture we did lag and autoregressive models. So today we will continue with a new topic which is simultaneous equation model. So let's begin. So today's topic is simultaneous equations model. Now, what is simultaneous equation model? Till now, we have been covering the models which were of which had only one equation. Now, if we have a model which have simultaneously n number of equations, then what will we do? So, suppose we have one model y1 is equals to alpha naught plus alpha 2 y2 plus alpha 3 y3 alpha m ym plus gamma 1 x1 plus gamma 2 x2 up till so on gamma k xk plus ut. This is the first equation model, and we have y2 is equals to alpha naught plus alpha 1 y1 plus alpha 3 y3 alpha m ym gamma 1 x1 gamma 2 x2 up till gamma k xk plus, here we can write u1 and here we can write u2. This is equation 1, this is equation 2. Up till we have m number of equations. Mth equation will be ym is equals to alpha naught plus alpha 1 y1 plus alpha 2 y2 up till alpha m minus 1 y m minus 1 plus gamma 1 x1 plus gamma 2 x2 plus gamma k xk plus um. This is the mth equation. So now we have to solve this equation, simultaneous equation model. All of these equations we have to solve them. So this is, as we have discussed yesterday in yesterday's class, this is autoregressive distributed line model because it has two variables y and x. So we know that x is equals to exogenous variable or independent variable. And y is equals to endogenous variable or dependent variable. So you can also learn it by endo, which means inside, and exo, which means outside. So someone who lives outside their home are independent, and someone who lives inside their home are dependent. So by this you can learn exogenous and endogenous variables. Now this here number of equations, we observe that number of equations is equals to number of endogenous variables, which is equals to capital M. In the previous slide, see, number of equations are M and number of exogenous variable are also M. So these two things are equal. And we know that, and now we can solve each equation by 2SLS method. We have discussed 2SLS method in yesterday's class. So 2SLS method. Two-stage least square method. Its full form is two-stage least square method. So in first stage, we will calculate or predict y2 cap, y3 cap up till ym cap simultaneously. And in second stage, we will calculate y1 cap. If we are talking about equation 1. And if you're talking about equation 2, then for in first stage would be y1 cap, y3 cap, up till ym cap, and second stage would be y2 cap. And similarly, if we are talking about mth equation, it will be y1, y2, y3 up till ym minus 1 cap, and final would be, second stage would be ym cap. So this is how we solve simultaneous equations. Now there are some notations. For simultaneous equation model, we are writing it as SEM. There are some important notations. So what are they? Capital M, capital K, small m, small k, k minus k, and m minus 1. Now what is capital M? Capital M is total number of endogenous variable in the model. As we can see, total number of endogenous variables are 1, 2 up till m. So total number of endogenous variables are capital M. Now this capital K is total number of exogenous variables in the model. Now we observe that total number of exogenous variables are x, your x1, x2 up till xk, x1, x2 up till xk, x1, x2 up till xk. So there are k, capital K number of total number of exogenous variables. So this is it. Now we will total number of exogenous variables, matlab we are calculating that x1 is there, x2 is there, not that x1 is also present in first equation, second equation, so it will become xm. No, different kinds of variables we are calculating. Now small m is number of endogenous variables included in a particular equation. Now, small m is total number of endogenous variable which is included in a particular equation. So, suppose this total number of exogenous variable is 2 up from 2 to m. So, m minus 1 it would be there. So, we have taken it as small m. And similarly, small k is number of exogenous variables included in a particular equation. Now, what is capital K minus small k? Now, if we subtract included from the total, we will get excluded. So, it will be number of endogenous variables excluded in a particular equation. Number of exogenous variable excluded. And similarly, small m minus 1 is number of exogenous variables excluded in a particular equation. So this completes our notation, and I hope these notations are clear with all of you. Now moving on, there are two kinds of condition. First is order condition and second one is rank condition. Order condition is also known as necessary condition and rank condition is also known as sufficient condition. So if our model satisfies order condition, then we can estimate we have then the result is that we can estimate the model. And in the second or rank condition, if the model satisfies that as well, then we can say whether our model is identifiable or non-identifiable. Now, what is identifiability? That is, our models can be identified or non-identified. So first is order condition, or it is known as necessary condition. So what does order condition says? If So if our this number of excluded endogenous variable is equal to number of excluded endogenous variable, then we can say our model is exactly identified. If number of excluded endogenous variable is greater than number of excluded and exogenous variable, then we can say our model is over identified. and if number of excluded exogenous variable is greater than number of excluded endogenous variable, then it is under identified. Now here in these two things, if our result come this, then we move to the next condition, which is rank condition. And if not, and if it is under identified, then our process stops here and we don't move further because our model is unidentified. Now the second condition is rank condition, or this is also known as sufficient condition. Rank condition or sufficient condition. So what does it say? Let there be Q. Q be a matrix having the coefficient of excluded exogenous variables. We will discuss this as we will do the question, then you better understand, and we will calculate rank of Q. If rank of Q is equal to, greater than, or less than. If it is equal to m minus 1, that means our model is identified. And if these two are the results, then we can say our model is unidentified. Okay. So if our rank, these two were the condition, rank condition and sufficient condition. Now we will solve one question so that you will be clear that what are we talking about actually. Let us take a question. Okay, so this is the question. These are the three equations. Equation 1, 2, and 3. Now we know that here capital M, first we will calculate the total. So capital M is total number of endogenous variable, means total number of y's, dependent variables. So 1 2 3, there is y1 y2 y3 in whole of the model, and nothing else, not y4 or y1, nothing else, so we will put 3. Now what is capital K, which is total number of exogenous variable, which is independent variable. There I can see only three variables, which is x1, x2, and x3, and not more than that or less than that. So capital K is also 3. Now we will solve this question simultaneously, equation by equation. That's why it is known as simultaneous equation model. So for the first equation, equation number 1. Here, first we will see what is the value of small m and what is the value of small k. So what small m is number of endogenous variable in equation 1. So there are 1, 2 and 3. 3 number of exogenous variables, and number of endogenous variable is small k. There is only one, x1. So we will put 1. Now we will for order statistic. Let us take this on the next page. For order condition, first we will calculate small m minus 1. Small m was 3 minus 1, which is equals to 2, and capital K minus small k, which is 3 minus 1, which is again 2. So now we can say k minus k is equals to m minus 1. So our model is exactly identifiable, identified, or you can say our model is exactly identified. Since it is exactly identified, or it would have been over identified, we would have moved on to the next part, which is order condition. Now, rank condition. So now rank condition. For rank condition, firstly we have to calculate Q. What did I say Q was? Q was the matrix of coefficient, which is of exogenous variable which are not present. So in first equation, which two exogenous variables are not present? X2 and X3, right? So X2 and X3 we are talking about. Coefficient of X2 in equation 2 is beta 2 and X3 is 0, and coefficient of X2 in equation 3 is 0 and X3 is gamma 2. So this will be beta 2, 0, 0, gamma 2. This will be our Q. So rank of Q, as we all can see, that rank is the number of rank is equals to the number of non-zero rows in a matrix. So here the number of non-zero rows is 2. So rank of Q is 2. Now what is capital M minus 1? Capital M was 3. 3 minus 1 is 2. Hence we can say that rank of Q is equals to capital M minus 1. And hence equation 1 is identifiable. Similarly, we can do for equation 2. For equation 2, firstly small m would be and small k would be. Small m is number of y's, matlab endogenous variable y1 and y2. So there are two endogenous variables. And similarly, k is number of exogenous variable, which was 1, only x2. Here only x2 is present, so it will be 1. Now solving similarly as we did for equation 1, first is order condition. Now what does order condition says? Order condition says that k minus small k. K minus small k is 3 minus 1, which is equals to 2, and m minus 1, which is equals to 2 minus 1 equals to 1. So k minus small k is greater than m minus 1. So our model is over identified, but we can move forward for rank condition, because I told you when we were discussing order condition that two conditions should come, either over identified or exactly identified. If under identified come, then we will stop then and there, but here over identified came, so we will move forward. Now the second one is rank condition. What does rank condition says? Rank condition says that we have to calculate q, which are the coefficient of q in of x's which are not present, x2, x1, x1 and x3 are not present here. So what are the coefficient of this? In the first equation, the coefficient of x1 is 0, and of x1 is alpha 3, and x3 is 0. And in third equation, it is 0 and gamma 2. Alpha 3, 0, 0, and gamma 2. These are the coefficients. Now again, rank will be equal to, because there are two non-zero rows, so rank will be equal to 0, 2. And capital M minus 1 will be equal to 3 minus 1, which is equals to 2. So M minus 1 is equals to rank of Q. Hence, we can say that our equation 2 is identifiable. Similarly, we can solve for equation number 3. So this I'm not solving. I will give this you as your homework, and you can write the answer whether this equation is identifiable or not in the comment section. If you have any doubt in this question or regarding this topic, then you can ask in comment box or on our WhatsApp channel, and only relevant doubts will be answered. And this is one of the most important topic in this ISS exam, because this has been repeatedly asked in the past few years, and the questions came exactly as I have done today. So keep on practicing more questions. We'll continue with this topic tomorrow. Thank you.